I'm so glad to be here. And yeah, we're going to go ahead and get started with the presentations. I just want to say that a little bit about the guiding principles that Gethin was talking about. As somebody whose real focus is bridging the gap between the patient community and the science community, those are so important, in fact, so critical. So I'm really excited to be here to work and partner with Gethin and to talk to these amazingly intelligent people and see the presentations. Just to make sure that you understood the format a little bit, we are going to go through each presentation, not taking questions after each, but rather going through the whole introduction of the Science Advisory Committee, asking them a couple of questions, and then we'll open the floor up. So just to make sure that you understood, we aren't skipping that, we're just putting that to the end. So I think with that, I'm not sure how this works on the first one, but I'm happy to welcome our first presenter, who is going to be by video, Janine. And I think you guys start that. Okay.
Good afternoon, everyone. I wish to thank the organising committee for inviting me to talk to you this afternoon about our newly formed ALS Africa Network. Before the Ice Bucket Challenge, the services for ALS patients in South Africa and indeed in Africa were all poorly organised. There was little to no African research activity, and although there was an NDA presence in South Africa, there was none elsewhere in Africa. In 2017, however, things changed. Michael Benatar, who is the principal investigator at the University of Miami for the research consortium called CREATE, in which is involved in phenotyping, genotyping, and biomarker development in ALS, invited us to join their consortium. Although we were able to phenotype patients, we soon realized that there was a need to cognitively phenotype patients in Africa. And indeed, there's no cognitive data on Africans with ALS. We then applied to the ALS Association for a seed grant to adapt and norm the ECAS, which is a cognitive screening tool that specifically developed for patients with ALS. And we then were able to do that for 3 languages spoken in the Cape Town region, namely Afrikaans, isiXhosa, and South African English. So the ALS landscape in Cape Town was changing. Patients were eager to join the CREATE program. They felt empowered by the research activity, even though they weren't able to access any treatment. Clinics got more organized, and we developed a closer relationship with our MND advisors. And here's a picture of the Cape Town group. But what was known about the epidemiology of ALS in Africa? There were very few formal studies. There were 2 community-based estimates of the ALS prevalence previously performed in Ethiopia and Nigeria. And the only formal study really was that led by Henning from Stellenbosch University in Cape Town. And that was a 4-year incidence study across the province, which showed that our incidence rates of ALS amongst our different population groups was similar to Asia overall, but less than in Europe. However, there were very many logistical problems, such as patients with a lower socioeconomic activity had less access to specialist care, and but it was the best that we could do. What is known about ALS in Africa? On the right-hand side of this slide, I've shown you data from our Cape Town cohort. And you can see here on the y-axis, we're showing the age at symptom onset. And we've organized the data according to the self-assigned genetic ancestral group of the patients. So African on the in the left group, mixed ancestry as well, and then European ancestry on the right-hand side. What is important to note is that all three different columns have got a very nice, what we would call a normally distributed data. So there isn't a excess bias on either end of the spectrum to suggest that socioeconomic or other factors might impact longevity. You also notice that the red line shows the average age of onset of the different groups. And the African patients, the black patients, the average age at onset is about 51 years compared to the European ancestry patients, which is almost 10 years older. The other important feature to note here is that the blue dotted line is the age at onset at 45 years, and most patients across the world are expected to manifest symptoms of ALS after the age of 45. But you can see here in Africans, this is not true. A large proportion of patients, in fact, have their symptom onset prior to age 45. And what is interesting, even though this is data collected now from our sample, Osuntokan in 1974 already observed this in his Nigerian data that was published in Brain in that year. However, as I said previously, we have got a limited data on genetic profiles, and cognition in Africans with ALS is yet unknown. A picture that I took from a 2017 publication in Practical Neurology, which is from the BMJ group, and it shows the map of what is known about genetic testing in motor neuron disease or ALS at the time. And you can see all the continents have got some presence on this graph, except Africa. So this is really one of the things we would like to change. Another important feature that I think I would like to highlight here is that I took this picture from the Clinical Trials Glossary from the Motor Neuron Disease Association page, and these are all the items that are explained to patients. And apart from biomarker, the other terms are really irrelevant in our context because we don't have access to treatment at all for our patients, and we would like to change that. So it really is, it was the call and the engagement of the International Alliance of ALS MND Association to change the landscape for all people with ALS across the world that really started us thinking about changing the landscape for Africans, and that we had to do it ourselves. We then submitted a grant again to the ALS Association, and they awarded us a seed grant again in October 2022 to start to set the foundations for the ALS Africa network. What are the aims of the ALS Africa? Well, we want to organize our clinics to become trial ready. We want to start patient support platforms in areas where there are no MNDA organizations yet. Maybe this can even be done by social platforms such as WhatsApps, where patients can receive support in remote areas. The clinics can provide multidisciplinary access, and we want to foster ALS research in Africa by Africans. So how did we start? Well, we have started by getting collaborators and colleagues that we knew from Nigeria, Professor Ogunya, Professor Soki from Nairobi, Professor Machen from also from South Africa, but in the northern parts of South Africa, in the Soweto, which is a city close to Johannesburg, and then myself really the four of us started the ALS Africa Network a year ago with virtual meetings, a common database that is shared and hosted by each different institution, a common informed consent documents for our patients, and we have now grown, and each centre have gathered a group of neurologists and speech therapists and other interested parties and researchers to really take our ALS Africa Network further in terms of clinic and development and support for our patients, as well as research development. So what can we do for our patients? Well, at the moment we can offer our ALS patients not really very much. In the clinic, the doctor is the treatment by and large. The research programs that we have started, which are mainly phenotyping and genotyping, are important because we will then describe the mutational landscape and at least draw attention to the different genetic causes for ALS in our patients. And Dr. Nell has a poster at the main conference to that. We can offer symptomatic therapy for cramps, drooling, anxiety. We can offer mobility support, sleep support, and gastric tubes if the patient is interested and would like to have that. And we aren't able to give patients respiratory support. The Motor Neuron Disease Association in South Africa have accumulated BiPAP machines over time, and they loan these to patients at no cost. But obviously there are only so many, so it depends on when a machine becomes available. And they can also loan things such as commodes, etc., if they have them available. What is missing? Well, there is a lot missing. We live in a limited resource setting. Some of our patients are well off, but a lot of our patients are not. And I have patients that are living in this kind of situation where they don't even have an inside toilet. We don't have any ALS treatments or trials, and we would like to change that. We need funding to catch up in terms of genomics research, and we need the support to really grow and sustain ALS Africa Net. I've mentioned that Nell has got a poster about the mutational landscape as we know it at present, and that really only relates to Southern Africa at the moment. But there are important scientific signals that can be explored with our data, such as the earlier age at onset, and possibly if there is greater resilience to ALS in our patients, if we truly have a lower incidence than the global north. And then finally, I just want to acknowledge Melissa now recently received Wellcome Trust funding to really kickstart ALS genomics for our partners in ALS Africa. Michael Benatar and the CREATE Consortium that supported us and mentored us and is still guiding us. The ALS Association for providing 2 rounds of seed funding to assist us. The South African Motor Neuron Disease Association, that has been amazing. The Alliance for enthusing us. And then, of course, last but not the least, our patients and families for their participation. Thank you very much.
Thank you, Janine. And just as a reminder, Janine will be joining us as the Science Advisory Committee and on the panel and questions after. So thank you, Janine. We look forward to talking with you. And we'll move next. I believe we have Tim Miller, Dr. Miller's video up.
Hello. Hello, I'm Tim Miller. I'm a neurologist, neuroscientist at Washington University in St. Louis, and I'm delighted to share with you some of the results for the studies of tofersen. I want to start with my industry collaborations, in particular Ionis Pharmaceuticals, with whom I've had the pleasure of developing antisense oligonucleotides, and you'll hear about one of those today. And also Biogen, with whom I've had the pleasure of running clinical studies, and I'll discuss with you a Biogen-led clinical study. As this group likely knows well, most ALS is sporadic or singleton, but about 10% of the time it's familial. And within that 10%, approximately 10 to 20% is caused by mutations in the gene SOD1 or superoxide dismutase 1. So if you're doing the math, that's about 1 to 2% of all ALS. And in the United States, that's about 300 to 350 people with SOD1 ALS. And though I'm not showing you, don't have the numbers for you today regarding the prevalence of SOD1 ALS in different countries, it is recognized in many different countries, though of course the numbers vary to some extent per country. SOD1 is superoxide dismutase 1. It causes approximately 1 to 2% of all ALS. It's a genetic change. So one letter in the genetic code that's changed, and that leads to toxicity to neurons from the abnormal protein that's produced. Lowering abnormal protein should decrease toxicity. That's the hypothesis that we're testing. Tofersen is an antisense oligonucleotide that's designed to lower the SOD1 mRNA and thus the protein. If you think of the human body analogy to a house, you think of the DNA as a set of blueprints or instructions of how to build and maintain a human body. The RNA would then be a rewrite of that set of instructions, less complicated. And then proteins would be the stuff in the house, a rug, a chair, the wiring. And when there's a change in the genetic code, there's a change in the RNA. And that change in the RNA and that set of instructions leads to building, instead of a normal protein, building a toxic protein. And when that toxic protein builds up, it leads to damage to neurons. Antisense drugs can block disease-causing RNA and proteins by blocking the RNA. So they block, or you can think of it as erasing, deleting that abnormal set of instructions. And when that's not there, then you don't produce the toxic protein. To discuss the results from the phase 3 SOD1 ASO Valor study. In the study, SOD1 was lowered. That's what this drug is designed to do. Neurofilament, a marker of neuronal damage, was reduced. The primary endpoint, the slowing of disease on a functional scale, was not met at 28 weeks. But if you look out at 52 weeks, then you begin to see that people on tofersen stabilize or may even show some improvement. This was a relatively small study with 72 people on drug, tofersen, and 36 people on placebo. There's a loading dose period where people in the study received 3 doses in the first month and then received 1 dose about once a month after that. The tofersen, like other antisense oligonucleotides, does not cross the blood-brain barrier. And so it's delivered intrathecally, and that's shown here, delivered into the CSF space at the lower part of the spine. And then after delivered here into the CSF space, it distributes all throughout the brain and spinal cord. I'm going to show you a couple of slides that look similar to this. Those that received the drug from the beginning in red, or we're calling early start. Those received placebo at the beginning in blue, and they're delayed start. Because at 28 weeks, this dashed line down the middle is the beginning of the open label extension. This is the time when everyone who wanted to was able to go on the drug. And this first piece of data shows that SOD1 in the cerebral spinal fluid was lowered. That's what the drug is supposed to do, lower the levels of SOD1, and indeed it does lower the levels of SOD1. We also looked at neurofilaments. Neurofilaments are structural proteins. They're intermediate filament proteins. They are part of the structure of axons. And you can think of axons as the wires that connect the brain and spinal cord to muscles. In the setting of ALS, these axons or wires degenerate, and the stuff within them, the neurofilaments, leak out into the blood and to the CSF. As you might imagine, neurofilament leakage is nonspecific. There are many diseases where axons degenerate, and as shown here, other neurodegenerative diseases like Alzheimer's and Parkinson's also have elevated levels of neurofilament. But in ALS, it's higher. So it is noteworthy that in ALS, the levels of neurofilament are particularly elevated. And the neurofilament levels matter in the setting of ALS. So if you look out here at 4 years after onset in a group with high levels of neurofilament to start, only about 20% of people surviving. Whereas if you look at this group with low neurofilament to start and look out here at 4 years after onset, about 60% of that group surviving. So neurofilaments matter. In the setting of this study, those on tofersen had substantial lowering of their neurofilament, as is shown here. And the group on placebo, once they got on drug here at 28 weeks in the open label, also had substantial lowering of neurofilament. Our interpretation of these data is a substantial slowing of the neurodegenerative disease process. We read out function by the ALS Functional Rating Scale. This is a 48-point scale with 4 different subdomains. You start with 48 points and lose points as you go. And at 28 weeks, the primary readout for this study, there was not much difference between those on tofersen versus placebo. The primary endpoint was negative. But yet, if you look out at 52 weeks, you begin to see the difference between those that were early start placebo versus those that got tofersen from the beginning. And you begin to see also stabilization. And I think this is best illustrated in my favorite piece of data from this published study, which is handheld dynamometry, or strength. It's a composite of a number of muscles showing strength. And you can see the group that got tofersen early has stabilized. And when we dug into this further, those that got the drug early, 27% of the participants that got the drug early have an increase in muscle strength. And I think, as many of you know, this is a really remarkable number for people living with ALS. For the 27% in this study showed improvement. And consistent with this, there were multiple really remarkable stories. I'll just share with you a few from the FDA Advisory Committee meeting. This is a woman with SOD1 ALS who says, since that first dose, I'm doing things I could not do and had accepted I would never do again. My limp has gone from an obvious disability to barely perceptible. I can go into my office again because I'm able to get up and down the subway stairs. I can shower without my shower chair. 43-year-old gentleman said, I feel my ALS has slowed down since taking tofersen. I've noticed my voice has gotten stronger, and having been in a wheelchair for months, I can now walk short distances that I haven't done since before tofersen. There are some side effects that are noteworthy. In particular, myelitis radiculitis, papilledema, increased intracranial pressure, aseptic meningitis, and some others. These occurred in 7% of those on tofersen and did not occur in placebo. Some conclusions. Lowering SOD1 lowers neurofilament, and this, our interpretation of these data is a substantial slowing of the neurodegenerative disease process. At the later time points, you see stabilization of function, breathing, and strength, and in some, evidence of improvement, which, and then there are some remarkable individual stories from this study. Overall, tofersen was well tolerated, but there are some noteworthy side effects, as I discussed. The 2-year data from this study will be presented by Dr. Merit Sokovich later this week at the ALS MND meeting. For sporadic ALS, I would consider discussing genetic testing. For symptomatic SOD1 ALS, discuss tofersen with your neurologist. And for asymptomatic SOD1 gene carriers, discuss ATLAS. And I've shown you the link there to the study. ATLAS is focused on the asymptomatic gene carriers, or discuss a monitoring plan with your neurologist. In the United States, tofersen has been named Qalsody, and I think, as many of you know, this drug was approved by the FDA in April of 2023. Some milestones. This is the first genetic therapy for ALS, the first FDA accelerated approval for ALS, and the first drug to show really substantial slowing and also improvement in the setting of ALS. Some thoughts about lessons learned for all ALS. Many viewing this may not have an SOD1 mutation. I think for me, the most important lesson is that ALS is a treatable disorder. Improvement is indeed possible. And that's really important for all of you to know, and for those of us who are focused on drug development for all ALS. It's important for us to know that if we have the right drug, we can have a substantial impact on the disease. Of course, in my opinion, tofersen is the right drug for SOD1 ALS. It's also important to understand that ASO delivery to the cerebrospinal fluid can be effective. This enables many other programs in ALS that are coming through, both for genetic and for sporadic forms of the disease. I think from this trial, we also learned that it may take time to heal. 6 months was not enough for tofersen for us to see a major effect. It took out to 52 weeks to be able to see those larger differences. So it may take time to heal. I want to recognize the many groups that have been involved in this over the years, as shown here. Also want to give a shout out to the study participants, the brave volunteers in this study, and their caregivers and their families. I want to thank them immensely. Also want to recognize the steering committee, as is shown here, and the principal investigators, and their very hardworking site staff, and my colleagues at Biogen, Steph Fredette and Toby Ferguson. I thank you very much for your attention today.
Thank you, Tim, for that presentation. If you're recording and reading back at this, I do need to tell you that unfortunately Tim isn't going to be able to join us at the end for the Q&A live today, but we do have plenty of capable people on the stage here with us, so we will keep taking your questions. If we need to, we'll get back to you on that. But at this time, I'm so honored to welcome in my American accent, Amar, to the podium for your presentation.
Thank you very much, Alison, and thank you for inviting me. So I'm going to be talking about the UK Motor Neurone Disease Research Institute. The reason I'm talking about that is it's a new way, I think, of coordinating and getting funding, and that's what I'd really like to show you. And it's also it's completely, essentially, patient-driven. So I'm going to tell you a little bit, you'll see the chaos of our political system as well during it. I'll tell you a little bit about how it came about. So the UK MND Research Institute is a virtual network of ALS research centres across the UK. And the mission is to accelerate the search for a cure. You've seen from the previous presentation very excitingly that we now know ALS definitely is something that potentially could be cured if we had the right treatment. And there are 3 goals that we use to try and achieve that. The first is to understand what is happening in the person who's affected, so understand the actual process of motor neurone disease, or ALS. I'm using the 2 terms completely interchangeably here, by the way. Then to develop potential treatments from that knowledge, and then to test those treatments in a clinical trial. So those are the 3 steps. So that's called the translational pathway. So it came about because in December 2019, Lee Millard, who you can see at the bottom there, and David Setters, both of whom I've known for a long time, but actually Lee I've known for something like 15, 20 years, contacted me. They're both living with motor neurone disease. And they said they wanted to see a step change in the way ALS research in the UK was funded, because they felt it wasn't really funded properly. And we had an initial discussion, and in that we went through the problems that you can see in ALS funding. Because if you're going to try and get a step change, it's important to know why you want to do what you want to do, not just what you want to do. And we thought what the problems are in funding at the moment, the funding landscape. So there's lots of them. The 2 main ones are that research is siloed. So when we apply for a grant, we look for what's called a grant call. So the grant-giving body will make an announcement and say, anyone interested, apply here. And then all of the different groups apply, but it's not a coordinated thing. So you might get 5 different people applying to 2 different funders for the same thing, and they won't necessarily know about it. And the second thing is the amounts of money that you get from those are very limited. A £200,000, so that's about $300,000 if we're optimistic, grant is really a big grant from our point of view, and yet it's pathetic in terms of what you can actually do with science with that amount of money, because people cost a lot of money. You want to do the research over a reasonable length of time, and most grants are really restricted in how long they'll fund you for. And the consumables cost a lot. So to do a single genome sequence used to be about $1,000. It's now about $300. So it's still quite expensive, so about €300. But it's now achievable at least. But you try doing that in 10,000 people, which is the kind of number you need to be able to get anything meaningful, minimum, that's €3 million. So how do we get all of that money? And the conclusion we came to was that we needed a BHAG, which is an actual thing. You can Google it. It's a big, hairy, audacious goal. And a big, hairy, audacious goal is something like a moonshot. So it's something where everyone can understand it. It's simple to articulate. Everyone wants it because it seems like a very desirable thing, but it also seems impossible. So going to the moon is a very good example of that. It's something everyone would want to do potentially, before we could go, of course. Something everyone would want to do. It seems impossible. How are you ever going to get someone to be on the moon, etc.? So our BHAG was to get £50 million from the UK government at a time when we had what's called austerity. So all of our public services were being stripped back. And how are we going to do that? So that was our plan. We wanted a UK motor neuron disease research institute, so that would be a single coordinated way of doing research and would let us get larger amounts of money over a defined period of time and act as a focal point for all research. So we had an initial planning meeting. Excuse me. You can see Sally Light from the Motor Neuron Disease Association and Brian Dickey there at the top. That was in February 2020, and we had our first formal meeting with 3 charities in total, so MND Scotland, My Name's Doddy Foundation, and the MND Association in July of that year. So this is during the COVID pandemic. This was our pandemic lockdown project. And we met Friday afternoons fortnightly, so that's every 2 weeks, for more than a year. We had the BBC take up our campaign and the Sunday Express, which is a newspaper in the UK that the readers generally vote for the current government of the UK. So if the Sunday Express takes up your cause, then the government will listen because it's their voters who are reading it. So that was very useful for us. And the Sunday Express said they would run a double-page spread every single week until the government caved. So it was a really dramatic thing for them to do. And we were helped because we had people with motor neuron disease who were sporting celebrities going on the BBC at a regular interval. And that was very brave of them, but also very useful for us. We met with the Secretary of State for Health, Matt Hancock, in December 2020. You can see the meeting down at the bottom there. And actually that's Doddy Weir, who's a famous rugby player who founded the My Name's Doddy Foundation. So we had meetings with MPs, ministers, the All-Party Parliamentary Group on motor neuron disease. These were all timed with the BBC appearances of the celebrities. So as soon as they appeared, within a day or two, we would be all campaigning and petitioning our MPs, because then they would be aware of it because it had been in the news. And eventually we had a parliamentary debate following a massive petition, which was done through Twitter. And we had a ministerial round table, so that's a way for the government to decide what to do. And then Matt Hancock was caught breaking lockdown rules, having an affair with one of his parliamentary aides. So he was sacked, and we had to start again with a new Secretary of State for Health, which is Sajid Javid. So we started with him. We're meeting him there in the top left. And he actually said, there's a very high turnover of staff in our government at the moment. If I say, yes, I'll support this, it's no use. I need to actually set things in place so that even if I'm sacked, I'll still be able to support it. And so will others, they'll carry on. So he said, it'll take a little bit longer than you expect, but it will happen. And he was true to his word. We didn't realize he was going to be true to his word. So in September of that year, we put a large 40-page document into the government spending review. And that document was coordinated from the major ALS research centres across the UK. So it was a scientific document. We also had 3 other documents. One was a single-page, very simple one for the MPs. Another one was a 3-page, slightly more detailed one for the civil servants. And the other was a very slightly longer one that was more technical for people who are interested. So all of those 4 documents went into the spending review in September, and we didn't hear anything, so we thought it hadn't been funded. And then in November, Boris Johnson, who was, I think, our 3rd or 4th Prime Minister at that point, I can't remember, made an announcement that they would fund the £50 million. And so the Sunday Express was very excited about it. So we'd been to Downing Street. You can see the people living with motor neurone disease there outside Downing Street. So that was very exciting. But making an announcement and actually getting the money out of the government are 2 different things, as we learnt. So we then went to the Secretary of State for Business, Kwasi Kwarteng, in the top right there, in November 2021, and he was very annoyed that he had to have this money out of his budget, and he was saying that it wouldn't come out of his budget, it would have to come out of the Department of Health, and the Department of Health was saying, no, it's going to have to come out of this other department for business, etc. So we had that kind of problem to deal with. Eventually, we managed to get 1 million pledged, which was already pledged, in fact, because it was an excess fund that they wanted to get rid of, but they rebadged it as for this, and so we said, okay, we'll go with that to start with. And you can see the planning meeting there at the bottom left with the scientists at another charity called LifeArc, which was very helpful in trying to coordinate everything between the government and then the 4 charities. So we had 2 government funders, Medical Research Council and NIHR, and the 4 charities. You can see us at the bottom right there going to Parliament for, I can't remember how, that was probably the 7th or 8th time, with 3 different MPs there. Then we had further meetings with yet another Secretary of State for Health, because Sajid Javid was sacked when the Prime Minister changed another time. So we had Steve Barclay to start with. And he was then sacked. Another one took over, Therese Coffey, and then he came back in. And before he was sacked, one of the things we were trying to get was the government to say this money would be ring-fenced for ALS research, and they refused to say that. But he was very annoyed that he was being fired. So in leaving, this is being recorded, isn't it? Forgot that. Anyway, in leaving, he said that the money would be ring-fenced for motor neurone disease research, and that was recorded in Hansard, which is our parliamentary document. He then came back as Secretary of State for Health a few months later, and so our patients were able to write to him and say, look, you said this money would be ring-fenced. And because he had said it, he had to honour that. And that made the money, getting the money a bit easier. So in February 2023, we had another roundtable, which you can see in the top left there, where we decided how the money was going to be spent. We actually formally launched with the first million. This is our launch meeting in November 2022, and the project started in January 23. And we now have all of the money, so this is how it's broken down. I'll go through that in a moment. I just want you to see the little thing on the right, which is the quote from Hansard, from Steve Barclay. He says, the departments welcome the opportunity to support the MND scientific community of researchers as they come together through a network and linked through a virtual institute. And the reason that matters is because in the UK, it's a criminal offence to call yourself an institute unless a Secretary of State has said you are an institute. So we can use that and legitimately call ourselves an institute. So the institute split is 1 million to this thing called the United to End MND Partnership Coalition. We've got £2 million for unified data support through Dementia Platforms UK and Health Data Research UK, which are 2 very large government-funded bodies that can link all of our data. They can make a single data spine, so all of the institutes have one centre for the data, and they can connect that with government information. So, for example, where does someone live? What's the poverty level like there, etc.? Is there lead in the environment? All those things. 12.5 million goes through another thing that's already set up called the Dementia Research Institute. 6 million goes through a thing called the Translational Research Accelerator, which is just the outline bids closed 2 days ago. And they've had, I think, quite a lot of interest in that. And then 8 million is a very nice little program called Experts ALS, where instead of using mice as the experimental model, we use humans as the experimental model. So where there's a new drug that comes out, if it's known to be safe, we give it to about 60 to 90 people, We measure their neurofilament level at the beginning and then about 6 to 9 months later again. And if there's a change in the neurofilament level, then we can prioritize that drug for further trials. If there's no change, it doesn't mean it doesn't work, because it may be that it takes 2 years for the neurofilaments to change. We don't know. You know, if you've got a milder treatment that's still very effective, it may not show up. But it's a way of saying, well, this one definitely has a big change and therefore we'll prioritize it. And then there's 20.5 million, which goes through the Medical Research Council using the old system. So we have to just do little siloed grants, which aren't very good, but at least it's better than nothing, and it's much more than we would normally have available to us at the Medical Research Council. So the 3 pillars, as I said, understanding the patient, identifying potential drugs, and then testing those treatments in trials. And we had the formal launch about a month ago. You can see my co-director there, Chris McDermott, giving a talk, and all the people there. There was plenty of media as well. And Amber Collingwood, you can see there, she's our senior project manager for the Institute. So the first steps, we've got a national stem cell resource. So that means when we when we test a drug in a stem cell, normally, if you then test that in another lab, there's often differences in the cells used or the methods used. For us, it's exactly the same in each place. And that means any changes you see, you know, are due to the drug, not due to the experimental error. We've got a national system for sampling all the patients. We've got national MND registers now integrated with research, so each person gets an identifier. We've got a telemedicine research platform that's just being developed so that people can answer questionnaires, they can opt into research, they can know what's happening through an app. We've got data linkage systems, as I said, where you can link all the different studies people are in. So if someone's in a clinical trial and they also give blood in another study, we can link them with their permission. And we have the clinical trials platforms. There's 3 of them. There's Experts ALS, there's the TRICALS system, which is a European system, and there's a thing called MND Smart, which is a UK-based platform. And then we've got training posts to build the next generation of researchers. And the benefits are we've now got national coordination of the MND research programs. The collaborations are larger and stronger, and you can see the funding was much more than you would normally get. It wasn't piecemeal. We've got unique programs of work that wouldn't have been possible with the old system. We're a focal point now for industry and pharma partners because they can just say, oh, look, there's the MND Research Institute, and they can contact us. And we actually have an industry liaison component of the Institute. And we've got flagship collaborations. So ChallengeWorks, for example, is it's the thing that launched the Longitude Prize, which is a historical prize, which is why we have watches. Actually, we're in Switzerland, so it's very appropriate. But to know where you are in the longitude of the world, you have to know the exact time. And so there was a competition historically launched out of Greenwich for whoever could solve making a clock that would still work when you were at sea. And that was solved, and so people had the Longitude Prize. So it's the same prize is now saying we would like a cure for ALS. We've got the Medicines Discovery Catapult, which is a system for linking with industry, and we've got the 2 data platforms. So these are all the charities that were involved, and you can see the 2 government funders at the top there. And I'll stop. Thank you very much.
Thank you, Amar. Okay, so now we're moving to the Q&A section. I'd just like to thank all our speakers. They were fantastic talks covering quite a breadth of research there. So we're now going to move into the Q&A, and please everyone start thinking their questions and put them through on the text if you're online. So first of all, though, there'll be we're going to introduce the SAC, the Scientific Advisory Council panel. I should introduce myself first, which I completely forgot before. So I'm Gethin Thomas, Chair of the SAC and also Director of MND Research Australia. And so I'll just start off asking the SAC to introduce themselves, and then we'll actually go through a quick Q&A with the SAC before we open it up to everyone else to ask their questions. So can we just start off with those online, please? Nadia, could you introduce yourself first, please?
Hello, everybody. My name is Nadia Sethi. I'm glad to be part of the SAC for the International Alliance. I work for ALS Therapy Development Institute, and I live in the United States. My husband was diagnosed with ALS, with a genetic form of ALS in 2019, and we lost him just 20 months after his first symptom. Glad to be here today. Thank you so much for having me.
We've already heard from Janine, so Adriano, could you introduce yourself, please?
Okay, yes, thank you. I'm Adriano Chiò. I am a neurologist and in Torino, Italy, and I'm leading the ALS center there with a lot of activities, including epidemiology and cognition, for example. Thank you for having invited me. I am a member of the SAC of the Alliance.
Okay. Dave, first up.
I'm David Taylor. I'm the VP of Research and Strategic Partnerships at the ALS Society of Canada.
Thank you. Hi, I'm Dr. Nick. I'm the Head of Research for the MND Association. Hi.
Hi, I'm Kuldip Dave, Senior Vice President of Research at the ALS Association.
And I'm Amar Al-Chalabi. I'm a neurologist at King's College London, and my research interests are genetics, epidemiology, and clinical trials.
Right, and now I think Alison's going to fire in with a couple of questions for the SAC. First up.
Thank you. Thank you. So excited to do this, and thank you for all being here. So every year I hear that we ask the members of this committee kind of what you're most excited about in the clinical research landscape or even preclinical research. But today we're going to mix it up a little bit. And we want to know a little bit more from you. So hopefully you got the memo that we did. We'd like to know from you what you're most excited about, what you think our biggest challenges might be as we go into next year, and how we might be able to address those. And so to give you a moment to think about that, on the stage here, I'm going to start online, just like Gethin did, and I'll start with Nadia, please.
Oh, yay, I get to go first. So I think one of the things that I'm so excited about is the approval of tofersen and Qalsody in the U.S. I think this is, I think hearing Dr. Miller's presentation today and seeing him say that there is a way to slow this disease, it's a remarkable thing, right? And we just need to do that for the rest of us now. And so that's the thing that I'm most excited about.
Wonderful, thank you. And we're going to go right through. We're going to ask everybody the same question, and then we'll start with the questions for them as well. So I'll move on to Janine.
Well, thank you very much for having me. I think for me the most exciting thing is the fact that I'm actually part of this conversation, and that the African continent is coming to the international table. We've come a long way in the last 10 years. It's going to be not an easy road going forward. I guess for the next year, the main challenge is to really consolidate what we've built and to try and get funding so that we can expand. And yes, I think that's probably the thing that excites me most, that we can possibly think of. By changing
Very specific, but it is for only a small group of patients. But anyway, in Europe, we have a completely different situation because all the drugs that have been approved in the US are not yet approved in Europe because the regulations are completely different. So from that point of view, we are a little bit disappointed. But anyway, I think that another major point is what Amar has presented, but in general, there is the group and the consortia are really growing in the area of research, both the clinical and translational research. So there are several groups both in US and in Europe. And I think that this is very important. We have, for example, Precision ALS in Europe that is collecting data from 15 different centers. 15,000 patients are now in the database. And this is a major point for new researches and new success in the area of therapy of ALS.
Thank you. Just quick repeating of the questions before we go down this line here. What are you most excited about? What is the challenge that you think we're going to face, and how can we address it? We'll start with you, Dave. Oh, did I miss
They
somebody?
didn't do the challenges. Are we going to do the challenges after? or-
Well, they did.
They
They
did?
kind of did. Yeah, were you listening?
The challenges? Really? I didn't hear the challenges. Okay.
I have some additional challenges, Allison, so we can
Okay.
come back.
Well, the
You
reason why I
know,
ask is
okay.
because should I do my challenges?
No, you know
or-
what? Good point. Thank
I'm
you.
just asking.
No, thank
Trying
you.
to follow the rules. My apologies.
We're making up the rules as we go.
Right. So we actually don't coordinate, so I come up with a bunch of them. So I will say that I was going to choose experts ALS, but Professor Al Chalabi already mentioned it. I will say this is one of the first times in recent memory for me that I've been at a conference where actually all the senior scientists were like, whoa, about something, but it's kind of hard to explain. It's really cool though. But I'm actually going to choose another one that I was at a conference this year and saw a bunch of researchers just floored with. And it's kind of a companion piece to tofersen. We don't know the results yet, so I should say that. But there is another clinical trial that is really focused, as Dr. Keogh said, on a very tangible, known target in ALS, and it's an antisense oligonucleotide similar to tofersen for FUS. And so FUS is a particular genetic variability that leads to a protein that can be toxic to motor neurons. And when knocking this down, there's preliminary evidence, and again, it's preliminary, so we don't have the results yet, that this is reducing the neural filament, which is really cool, and that there's some evidence, anecdotally again, amongst clinicians and around the field that this may be benefiting people. We don't know yet, but the preliminary data is really impressive. And so if that works, then we're really on to something that if we hit the right target at the right time for everybody, we can actually make this treatable disease. So I think it goes alongside with what Dr. Miller said in being a second piece of that proof, which is really cool.
You didn't say what the challenges are. I'm kidding. Yeah, so I'd echo what Dave said. So that preliminary evidence for that fuzz gene, just to add, is about 1% of all MND. So just to put that in context. So yeah, I'm you know, it's never a good time for MND, but I think there are more discoveries going on at the moment, and certainly the optimism and the hope that these gene therapies have given to everybody. You know, it's not an answer for everybody right now, but it just shows that MND is treatable, which is absolutely incredible and a really huge positive that's, you know, driving everybody forward. So that's a really great thing. I do have a few challenges around all of that, but also the real excitement of that is when you take a deep dive into what's actually going on in the labs all over the world. There's other therapies for not just the small percentages of genetic caused MND, well, other genetic causes as well. So actually there's a lot of things coming over the horizon. So this has shown us that some of these things can work. So it's an incredibly exciting time, and it just shows that science is pretty amazing, the things that people are doing. So I'm very optimistic that we're going to have something effective and significant in the near future. So that's all from me.
So for me, I would say it's really exciting to see the amount of attention and funding that's going up, and coordination between nonprofit organizations. Amar just showed, $50 million in UK. Gethin talked about the collaborative effort in Australia. We're seeing that in the United States as well. National Institutes of Health this year is going to fund the same amount of money in ALS as they're going to put into Parkinson's, which is 20-fold more Parkinson's patients, at least in the United States. And we're getting the same amount of funding. That's not enough, but point is that as funding goes up across the world, it allows ALS Association, for example, to look at areas of research that are not funded. And so I'm really excited about two areas that we're focusing on. Not that we are giving up on drug development, we're funding that, but we're focusing on assistive technologies as well as quality of care research. As we make ALS a livable disease, those, and as drugs come online, assistive technologies and quality of care is what's going to take people with ALS forward as they live with the disease. And so I'm excited about that.
So for me, it's clinical trials. When I started, and until about 3 or 4, so I started in 1994 in ALS research, so nearly 30 years ago. It'll be 30 years in February. I used to have less than one trial to offer my patients a year on average, and that was true until about 3 or 4 years ago. Now we have 6 or 7 in the UK. That's true across most places. There's probably more in some countries. I know there's not many in Africa. That's terrible, and it is something we need to fix. The reason it's exciting having so many trials is because the faster you can do trials, the more drugs you can test, and the more drugs you can test, the quicker you'll find a treatment that's effective. So that's very exciting. But the reason we have a lot of trials now is because we're getting better at knowing what the target should be. And you can see that if you write out all of the trials over the last 30 years, nearly all of them have been unsuccessful and haven't shown any benefit. But if you look at the ones that have been licensed somewhere, so someone thought, well, maybe they do work, or you look at the ones where there wasn't a clear negative, then the hit rate is slightly different. You get nothing, and then you get something, and then a big gap with nothing. And then the last few years, you get 3 or 4 where something has happened. So that's telling us we're getting closer and closer, we're getting better and better. And to me, that is exciting if you combine that with the increased number of trials we've got.
What I'm excited about leads on from what Janine was saying before, that we are seeing a much better globalization. I had the pleasure of attending PACTALS earlier this year, and there was a really significant pharma presence there, which I don't think we've seen before, just showing that they're looking at Asia as expanding their clinical trial presence there, I think, and that's very exciting. And then we heard just before from Kuldip and Jess about the global south. So I think it really is moving into a more global situation.
Love that. Okay, thank you, Dave, for pointing out the question. I'm going to go back to the online members very quickly and give you an opportunity if you could answer both the questions at the same time. If you have any challenges that you're aware of and possible solutions to addressing those. Nadia?
Yeah, I'm sorry if I threw everybody off at the beginning.
Good.
Challenges. I think many of the people on the panel have spoken to this, but there is a discrepancy between treatments globally, right? So some countries have more treatments approved, some have less approved, some have none. And so I think this is going to bring on some challenges with planning clinical trial design in the next few years. And I mean, in some ways, it's a good problem to have, right? Because now in some countries we have options, but that also brings on challenges with, how do we design a trial that might be in many different countries, and you're going to have different groups of people who are taking different approved drugs. And so the good thing is that we're also at a point where we are looking more at biomarkers. We're not just looking at, a change in function in people or measuring survival. And so we have better tools to deal with this. But I think that the MND Symposium, the International Alliance meeting, these are wonderful places to have those discussions. So I'm hoping that you guys on the ground over there in Basel are going to come up with some solutions for this as we are planning our next trials that are coming up.
Thank you. Janine?
Well, thanks to all the speakers for hearing us and for acknowledging us. I think the biggest challenge really is human resources for us to get more organized. Yeah, that would probably be funding to support nurses, to support researchers, to support so that we can just get our clinical clinics that are giving care more organized, so that we're ready to perform trials. In some instances, we are ready, but I would like more centers of care to be ready. Thank you.
Wonderful, thank you. Adriano?
Yeah, well, the major point for me, the major challenge is equality. Equality both within countries and among countries, and in particular when we consider a different aspect. The presentation by Janine was really illuminating from that point of view. This is the problem of research in Africa, but also in other countries. For example, in South America is still in a very initial phase. The problem of clinical care, which is probably the most important for patients, people with ALS in these countries, and the access to treatment, because we have now, at least in US, in Canada, they have 4 different treatments, but the cost of the treatments is probably absolutely impossible for people living in South America or living in Africa. So probably this is a major challenge, and the solution could be some work with the companies producing the drugs in order to give them to a different price to these countries, in order to make people there to have the possibility to be treated.
Wonderful, thank you. We'll come back on stage here. Just a quick repeat of the questions, if you can answer them both at the same time. What do you think are biggest challenges going into 2024, and do you have any solutions for that? Dave?
So I'm not going to go about globalization, but I'm a huge fan, Janine, of your work and of what's happening with ELATEM and elsewhere. I'm going to take a slightly different spin on it. One of the things that's got mentioned at this panel for many years, and just recently had sort of a public discussion on, was the brainstorm trial, Neurone. This put us in I'm going to talk about communication, I'll say. So this put us into a situation in the field that we have never really had before, where clinicians weren't really speaking up. It was a difficult situation. There were a lot of people who were hurt and misled over a long period of time, and organizations were put in a very difficult place to be able to speak about this. And I see us moving into 2024, and we are going to have some challenges in terms of communications. There are approved therapies by incredible companies that are supporting our field very, very well and very, very much, that are both going to have complicated answers coming up. We're going to have the ADORE trial, which is going to be a Darvon in Europe. It's going to read out. We're going to have Amylyx's phase 3 Phoenix trial read out. There are discrepancies between what clinicians feel about these therapies in different places in the world. There are going to be other therapies that are going to come in with data looking for flexibility, and we're going to have complications in understanding whether or not these should be approved, or whether we're going to be too flexible, and how are we going to know downstream whether these actually work. And we're going to just have more clinical trials. And it's an awesome thing, but it's also complicated. And I think if we're feeling it's complicated, and clinicians are feeling it's complicated, I can only imagine how complicated it is for someone who's newly diagnosed with ALS or MND. And so what I hope the solution is that we can all have each other's backs, talk openly, transparently, and bluntly about these things, and come to some conclusions, some answers together with the clinicians, with industry, be partners, be collaborators, and always remembering at the end of the day who we are here for, which is the people who are living with this disease, and hopefully provide them really solid and good communication on the decisions and the things that happen moving forward. And that would just be fantastic. So I hope we can do that.